Hello, welcome to our video for Chapter 9, Lesson 8, which is the good old-fashioned multiplication algorithm. So parents at home, this is the one that you were taught, and for those students at home, if you go ask your parents, they'll know exactly how to do this. So we have a word problem here. Michael has 256 hockey cards. Pedro has twice as many. How many hockey cards does Pedro have? So you need to know what it means right here, twice as many. That means double, okay? It means multiply by 2. So that's what we're going to do. We're going to write down 256 times 2. Now, please note that the 2 and the 6 are both in the ones place, so they are lined up above each other, okay? All right, so to do the algorithm, it's really quick, just a matter of remembering the steps. So let's multiply the ones. 6 times 2 is 12. So you're going to put your 2 in the ones place, and you're going to regroup the 10, which is a 1 is the digit, but it's really a 10, to the tens place. So that's where 12 goes. Let's move on to our tens. Multiply your tens by 2. So 5 times 2 is 10. Add your 1 to make 11. So we're going to put our 1 down here and our next one up in the hundreds place. And finally, multiply your hundreds by 2. So 2 times 2 is 4. And add your 1 to make 5. So your answer is 512. So you can see how much faster this algorithm is than doing the expanded form version, but you do have to memorize those steps. So I'm just going to show you now what that looks like with a place value chart. So you can see exactly why these steps work the way they do. So we're going to draw a place value chart, hundreds, tens, and ones. And the number that we are multiplying by 2 is 256. So we're going to draw that. So we need 2 hundreds, 5 tens, and 6 ones. So that's 256. And we're multiplying it by 2. So we're going to draw it twice. So come down to a new row. Try not to jumble them all up together. So here we have 2 groups of 256. Now, along the side, I'm just going to write our numerals, 256 times 2. So this is how we can show it using base 10 blocks. 6 times 2 is 12. So that's what we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But we can't write down 12 in the ones place. So we're going to circle 10, 6, 7, 8, 9, 10, and we're going to regroup it for 1 tens rod. So now we don't have 12 in the ones place anymore, we just have a 2. And what that looks like here, 6 times 2, we put our 2 in the ones place and our 1 in the tens place. So we're doing the same thing with our base 10 blocks. Okay, now let's see what 5 times 2 is. 1, oh, okay, undo that. Always changes to my eraser. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But don't forget, we have this one, 11. So that's how many tens we have right now, which is the same as if we went over here. 5 times 2 is 10, plus that 1 is 11. But of course, we can't write down 11. That can't happen. So we're going to circle 10 and regroup it to the hundreds place. So we're going to change that into a 100. So now we're not left with 11 anymore. We're left with 1. So we're going to go 5 times 2 is 10 plus 1 is 11. Here's 1 down below and 1 in the hundredths place. And finally, we're going to go to our hundreds, and we have 1, 2, 3, 4, 5 hundredths. So here is our answer, 512. 2 times 2 is 4 plus 1 is 5. So this base 10 block is just showing you how exactly that algorithm makes sense. So if you can remember the steps on how to do that algorithm, it'll be way faster for you than using expanded form. However, to each their own. If you're more comfortable using expanded form, then go ahead and do it that way. If you have any questions for me, please feel free to contact me. Thank you.